Hey everyone, welcome back. So we are getting started now. The coming session is about graphs and Vogue Dance using data structures to create choreographies. So this amazing talk will be delivered by Alynne. Alynne is here. Alynne, please welcome to the rise.
Okay. Hello. It's working. Hi, guys. As you are seeing, I will talk about graphs and use the Vogue Dance to explain that. Who am I? I'm Alynne Ferreira. This is strange in Portuguese too because sometimes Aline is just with an I and an N, but yeah, my name is like that. I'm a computer engineer, and it's just a photo that I like for my graduation. I'm a backend developer, and that's my back. Yeah. I'm a dancer, and that's why I choose Vogue. And when I say I'm a dancer, I'm really into it because it's a presentation. Just that. And the most important, I'm Brazilian. There are Brazilians here. I forgot to start the timer, but okay. This is the table of contents. We talk about Vogue, graphs, directed graphs, tree, how to mapping the poses, automata, and a little about the application. What's the motivation about join two really different things? I really wanted to talk about dance in Python Northeast or Python Brazil. I don't know, just because I like. I really wanted to talk about graphics too, but I don't know, sometimes the technical talks is not boring, but it's too hard to understand. And I like interdisciplinarity. So for me, it's not a problem to see talks about Flask, Django. I really like it, but I like to, I don't know, to play with, yeah, with technology. Uh, so when people show us how to use technology to solve problems about health, about arts, about oceanography, oceans, I like it too because it's nice, it's cool, and yeah. And I have group dance. So when I started this talk, I had to do a choreography, and my group was invited to dance in a beauty fair. I don't know if the translation is right, but it's, I don't know, a conference about hairs and makeup and things like that. So I think about Vogue because it's glamour and shine and ooh, and that's it. And I will talk about Vogue. The first thing came to my brain when I think about Vogue is Madonna, maybe for you too. And it's interesting because I started this talk before it happens, but she went to Brazil, and it was the the biggest concert in Brazil, I think, and it was in this month. But Vogue is not just a dance, it's not just a music, it's not just Madonna. Vogue is representativity. It was born in New York, and unfortunately, I didn't go to New York. But it's really nice to talk about Vogue in the USA because it was born here. And they have the concepts of ballrooms and house. And I don't know, I laughed a little when I saw I will do this talk on a ballroom. But it started between the 17th and the 18th. And how it started. There were Miss Battles, but these battles was the judges was white people, so it's really hard to black and Latins people to win or sometimes to participate of it. So it started to have the Vogue battles, and I think it's cooler because it's not just walk, walk, and pose like the misses. It's really dance and keep moving. So it's, I don't know, for me it's really better. Sorry, it's really better. And about the house, it's interesting because I don't know if it's major. The major part of the people were LGBT. So it's hard now, but when it is 70s and 80s, it's worse. So most people were excluded for the families. And house is not just house, but home. It's not where people go to live or to join a group to learn how to dance. It's a family. And it's really nice because people, us as people, need the community, need family, need friends. So dance provided it, so for me it's really nice. And graphs. Why graphs? Graph is an abstract representation of a set of objects and relationships between them. In plain English, it's a set of vertices, edges, and function that associates each edge with a pair of vertices. Just a second. So if we think in mathematics, we have a group A with 1 and 2. We have a group B with 2 and 4. And we have a function that link both when you think maybe 2 times. So if I have 1, 2 times, we will link this 1 of group A with the 2 of group B. And we have the 2, we link it with the 4 because it's the times 2. So it's quite similar. So we have inside all groups the empty group. It's similar with graphs too. So I just put a white square and a black line. No, kinda, but no. There's code. We import these 2 libraries, the matplotlib and networkx, and this is the magic. We create the graph using the function graph. We put on the Spring layout. There's other layouts, but I chose that. There are the subplots, and this is the magic about the edges. So use the draw network X. We put the graph here. We put the position. We set the arrows to true because we want it to appear. And the arrow style, in this case, is just the hyphen. It's possible to change, but in this case, just hyphen. And we have the source and target margin. It's about the size of the node or the vertex. And we want to show the label, so it's set to true. This is the trivial graph. A graph is trivial when it has just a node without edges, just the node. And the difference between this code and the previous is because I use the add node 1, and this one is the label. So that's why I have to have this label as true. We have the connected graph too. And a graph is connected when if I choose any node, it's possible to arrive any other node using these edges. So if I choose 1, for example, and I have to arrive in 4, it's possible because I can go to 5 and 4, and you can go to 2, 3, and 4. And the code is a little different because we are not adding nodes, we are adding edges. And just 1, 2, 3, 4, 4, 5, 5, 1. And it's nice because it also works if you only create the edges. So if I have an edge linking 1 and 2, the library will understand that we have the node 1 and 2. So you don't need to create a node. So if we have the connected graph, we have the disconnected graph too. The difference is easier to see. I remove the last edge. So the 4 is here. And if this 4 doesn't have an edge, I have to declare it explicitly. So this subgroup is connected, but the graph is disconnected. We have the complete graph, but to understand the complete graph, we have to understand the degrees. A degree is a number of edges one node has. So in this case, you have the 2, all of them, but we have 2, and in this node 2, it has 3 edges. So the degree of this node is 3. And to be a complete graph, all the nodes has to be in the maximum degree of each node. And to understand it better, if I have 4 nodes, the maximum degree is 3, because in this case, we doesn't count an edge that link itself. So it's just a node for another node. And it's the same, I just put it to, I don't know. If I have the complete graph, we have the incomplete graph too. The code is similar. I remove the last line that links the 3 and 4. And how I know it's incomplete? Because 3 and 4 has just 2 edges, and it's not the maximum. So if just one is not in the graph, in the maximum degree, so it's incomplete. And we have the loop. A loop is when an edge is linking a node with itself. In the code, it's really similar. We just have to put 2 and 2 in this case, because we are linking the node to itself, just that. And we have to the directed graphs, because sometimes the direction is important. If we think about um, city traffics, I don't know the translation, but we have the lines, so the direction is important. And we can draw it using graphs too, so it's important to have the directions. It's the same graph as the before, as the last, and the difference is just the arrow style. We can use the hyphen and the chevron to say it's an arrow. And when we do that, this turns into an arrow. Tree is not important to create it. Keep calm. For my case, for choreography, tree is not important, but I think it's important to explain to you. And there's a lot of types of trees, but I choose the binary tree because it's easier for me. And we think about a tree of nature, a real tree. We have a root, where it starts. We have leaves, that were, sorry, that where it ends. So in this case, we have the 5. This node 5 has 2 children, 2 and 7. The 2 has the 2 children, 1 and 3, and 1 and 3 has no child. So if a node has no child, it's a leaf. It's the last of the chain. And we have this function is tree. We put the graph, and it will return true or false to say to us if it's a tree or not. And I don't know if it's famous for you, but in Brazil, we have a game named Daquineiro. It's in English, so I think it's famous here too. And it's a question game. Alexa has this skill. And it works using binary tree. I'm not sure, I didn't see the documentation, but must sense it's a binary tree. So let's think about some questions. So here's the start. We have a group of nodes about singers, and a group of nodes with non-singers. So the coordinator will ask, this singer is a Latin woman, and I'll say yes. So it will ignore that and come to here to the 7. And it will ask, this singer is Shakira? So it came to here, is Shakira? And I'll say, no, she's not Shakira. So it came back to the 7 and asked, the singer is Anira from Brazil? And I'll say, yes. So it wins, I lose, and just fine, start again, and things like that. But I'm saying about graphs, about directed graphs, about trees, but how can I mapping the poses using that? The label is not just numbers or just not just letters. I can use photos too. So it's me in my house doing poses. For each node, I put it, and it. Just, I don't know, the 3 poses I know, and I put on the graph. And it's the possibilities to walk the pose. So I'm here, and I can go to here, and a lot of times here, or go to here. So in this example, I always will start here and end here. Or you want a photo? I didn't understand, but okay. And it's a representation, but it was not sufficient to solve my problem. Because I know these 3 poses, but how can I create a choreography using them? I have to think and try all the possibilities. I don't know, it was not sufficient to my case. So I forgot. This is how I can load the images. I use the pill, and I add to the nodes, and put here the image, and set the image of the dictionary. So if the graph is not all I need, I search another library that solved my problem, and I found the automata. And this is the code, and this is the definition. A deterministic finite automaton, a DFA, is a finite state machine that accepts or rejects strings of symbols, generating a single branch of computation for each input string. So to explain better, it's a directed graph, so the direction it's important, with a start and an end node. It's the example of the documentation. I lost my... Okay. The Q0 is the initial state, and I know that because of this arrow. The Q1 is the last state, and I know that because there are 2 circles here. And this is what I will walk on this graph. We have zeros and ones, and I will just go there and so on. And how to draw this graph, this state machine? This is the code. It's for the documentation, so it's simpler. We import the visual data, the visual DFA. We set the states, in this case Q0, 1, and 2. We have the input symbols, the 0 and 1, and we have the transitions. So if I am on the Q0 and I choose the 0, I go to itself, the Q0. If I choose the 1, I go to Q1, and so on. We have the initial stage, in this case Q0, and it's just possible to have one initial stage because it's a state machine. For dance, it's not, I don't know, we can start whatever you want, but for the state machine, we will start here. But for final states, it's possible to have more than one. In this case, it's just Q1, but it's possible to, I don't know, I have to finish here. Whatever I want to finish, it's possible. And we show the diagram with you set as true. I think it's the default, but in the documentation it's like that, so I just put here. But okay, it's the automata, for example. But how I draw mine? So how I use that in my application? This is quite similar to the last graph, but it's bidirectional. So it has directions, but in this case, you go to one from another and you can go back. So that is two directions. And we have the states, Q0, Q1, and Q2. The input symbols for facilitate my life, A and B. And the transitions. So Q1 can go to Q0 can go to 1 and 2, 1 to 2 and 0, and so on. The initial state is the Q0, and the final state in this case is Q2, but if you want, I can show with another final states too. So I have the draw of my graph, and I will use the input strings to see if it's accepted or rejected. Once again, for dance, it's not really important. I can finish whatever I want, but it's just to show how it works. So if you imagine we start here in the Q0, a lot of photos from Brazilians, and we use the A, we can go to here, from here to here, and then it's A again. I'm a little lost. Yeah, it's A, we go to, it's not right. I'm here, and with A, I'm go to here, and A with here. Why it's projected? I tested that. Q0, A, Q1, Q1, A, Q2, R. Okay. And after the Q2, we go to A again, and we return to Q0. So it's rejected because the final state is not there. It's another example. I will try to do it slower. I'm here on Q0. I have A, so I go to Q1. I have B, so I go back to Q0. And A, so I go to Q1. It's not the final stage, so it's rejected. As simple to show how it looks like if it's accepted. I start here again on Q0. I go to Q1 using the A, and to Q2 using the A again. So it's a final stage, so the string is accepted. But okay, I just put things I know what it will end. But if I just type in my keyboard, I have this example. I will not do that because it's so hard. But if you can see, the log show the transitions. So I have Q0, A, Q1, Q1, and so on. You can try it if anyone wants to, but I will not do that. And that's it. This is the references. I put the codes on this first link, the repository in GitHub. This is in Portuguese because I do this in Portuguese, and I didn't I didn't search references in English. But we have films and series. I know more about Vogue when I watched Paris is Burning. It's a film like documentation. And there are these two series, Pose and Walk, and a lot of series. I didn't watch it, but people says it's really amazing. So that's it. Thank you. If you have any question, we have 5 minutes. Yes. Any questions? Okay.
So if there are any questions, you can make use of the mic.
Just. Okay. Uh, yeah, so thank you for the presentation. It's like interesting conception of graph applying to such a topics. But have you thought about using like machine learning models with a pose detection and plus with your graph? Because you can implement something like a personal coach in Vogue that would like monitor your moves and seeing are you accurately in reproducing that.
I didn't think about that, but it's really nice. Uh, yeah, it's really, really nice. I will say that. But yeah, I think if we can get the poses and do it automatically, it would be so nicer because I don't know, I have limitations about poses. So no, I didn't think, but I will because it's really nice. So
Yeah.
thank you.
Thank you.
Thank you.
Here, okay. First things first, congratulations.
Thank
Love the
you.
presentation. It's a very creative approach in regarding to graphs, so kudos. And I'd like to know if you have your project, your initiative has more next steps, like if you want to try with another models, another dance styles as well, why not? So I'm very curious what you think to do in the future. Thank you.
I don't know, but I really like the idea of getting the poses and do automatically. I really will search how to do that. But the first time I did this task, this talk. People say about forró, and I forgot to say that about the forró thousand, but okay. And yeah, and a woman asked me about the figures in the, I don't know how to explain that in English. Because we have some, I don't know, some possibilities in the, I don't know the name of this, or the floor, to make choreographies. So it's possible to, each person can be a node, and I can organize them. And I don't know, I'm here, and in the next figure, I'll go here. So it can be a possibility too. Anyone?
Any more questions?
No? Who will
Oh,
dance here? Nobody? Okay.
so if there are no questions, thank you so much, Alin.
Thank you.
It's a wonderful talk.